Hello, and welcome to this lecture about vector data analysis or spatial operations. This lecture will be divided into three parts, and this is part one, where we will talk about basic vector operations and what they look like and how the computer solves these issues. So basic vector operations can be, for instance, computing distance between different features. When we talk about distance, we need to understand that there are different distances available to calculate, actually. We have the Euclidean distance, which then is the shortest route between 2 points. We may have a distance in a network. If we have a city, for instance, and a car or pedestrians will need to follow the existing network. And then we would have another distance, of course, not the Euclidean one. And then we may have a topographical distance if we're out in the landscape and hiking, for instance. We may need to climb up and down a mountain in order to go from A to B. And then we also have spherical distance. If we have a very long distance, we have to take into consideration the Earth rounding. And how do we really calculate the length of line objects? Well, not we. How does the GIS work in order to get you the distance? And this lecture will also talk about how polygon areas are calculated. Okay. So the Euclidean distance, the shortest distance between 2 points, is solved through Pythagorean theorem that is very useful in this case, where we have a right-angled triangle between 2 points. And if we know the x and the y, we can calculate the Euclidean distance between these points through the Pythagorean theorem that tells us that the square of x plus the square of y is equal to the square of z, the hypotenuse, I think it's called. So that's what the GIS program will use. And the x and the y is then, of course, achieved by comparing the x coordinates for the 2 points. So we have an x coordinate here, and we have an x coordinate here. And by subtracting one from the other, we will get this distance. And the same for the y distance here. We will get the distance by subtracting the y b, in this case, with the y a. So then the computer has solved these two sides of the triangle, and then it's quite easy to calculate the hypotenuse in that triangle. So now a line feature is normally not only 2 points. It is probably a start node somewhere and some vertices between the start node and the stop node that sort of defines the line segment. So the line segment consists of multiple coordinate pairs, and between each breakpoint, the program will have to calculate the distance and then add this distance to the distance, and then add this distance. So it will solve it by summarizing many small distances into one summarized distance. As you know, the line feature just consists of a coordinate pairs. So here we have coordinates, here we have coordinates, x and y coordinates, here we have x and y coordinates, and here we have x and y coordinates. So for each of these legs of the line feature, it will have to calculate the distance and then summarize it. Now, if we have a road network that we need to follow, then it will have to do that multiple times. For the first line segment, 1 here, it will have to calculate these all small distances and then summarize them, and then start with the next segment and add that distance to the total distance, and so on. And finally, it will have reached the destination and summarized all those distances into one. Then we have followed the network available in order to go from A to B. And for a network analysis that I talked about a bit, where we sort of the fastest or shortest way to go from A to B, then this will have to be calculated multiple times for all segments available, because in order to find the shortest distance between 2 points, because in reality it doesn't know if continuing this route will lead you back to B in a shorter way than going this route. We can see it, but the computer doesn't know it, so it will have to test all different possibilities. If we're out hiking, we know that sometimes we have high mountains, or at least a hill that we need to pass, and we may go around it, but if we go over it, it will be a short horizontal distance, but then we would need to add actually the topographical distance to it by moving up the mountain and down the mountain. So we would go from A to B, for instance. We would have to go up this hill and then down in this valley and then up again. And that is, of course, a longer distance than just the horizontal distance between A and B. But by adding Z, the vertical coordinate or vertical length into the Pythagorean theorem, we can actually calculate a topographic distance. How far am I really going? What is the distance when I have to go over a hill or down a valley? So that is possible too. Sometimes we will have a very long distance. If, for instance, an airline going from Europe to United States will have to follow the sphere, and then we would have a spherical distance, take into account the Earth's surface rounding, or the Earth's circumference, omkrets. Okay, so now we know how distances are calculated in the computer by the GIS program in order to give you the distance you actually are looking for. It's quite many calculations, but the computer is, of course, very quick and efficient in doing that. Now, to compute a polygon area is, we can see it as maybe it's easier for us to do it. We can see it, the object, the polygon, but how is it really done? Because we only have, in this case, we would have 4 different coordinate pairs, one here, one here, one here, and one here. And then the 5th one is, of course, the same as coordinate number 1, or the corner number 1. So in order to solve that, in the computer, we have to define the corners, and giving them some sort of numerical value. So 1, 2, 3, 4, and 5. Then it's told to move clockwise. The first node is equal to the last node. And then the compute area is using a formula that you can see down here, where we have we multiply the sum of the y the y coordinates multiplied by the x I plus 1 minus x I minus 1. And what does that really mean? Well, I is always where you are in an iteration. So if we start with I equals to 1, we are at the corner number 1. And then the x value for x plus 1 is then this point. That's the x value for number 2, x plus 1. And this one deals then with x minus 1, which then is this one. So it will use the coming coordinate pair and subtract the coordinate pair that was behind it, or I minus 1, and multiply it by the y value for the first corner. And then it will move to the next